And so going on that, like let's say in this biocompatibility example, hypothetically, what kind of problem solving tools or skill sets have you developed over this specific role that has really helped in, you know, kind of that intersection between your material science background and now like this environmental compliance?
I think it's actually a mix of those two and also these interpersonal skills that I think are so critical for engineers to have and to use and to build. For an example, this is a perfect, I think, an intersection of that.
Well, hello everyone. Welcome back to the It's a Material World podcast. I'm your host Puneet, and joining me today is my co-host David. How's it going, David?
Pretty good. Yeah, I just got back from some travel. So I'm back home for a little bit. Sounds like I'll be doing even more travel. So yeah, I'm really getting my sky miles in. So going around the world.
Yeah, I know we were just talking offline about getting global entry. I think it'll definitely be worth it, but that's a process in and of itself. So there's a time consideration there. But I'm also doing a lot of traveling coming up too, like moving first of all to Chicago. I know I mentioned that in the previous episode, but then also going to India for my cousin's wedding. So going to be a lot of back and forth, a lot of traveling, but we'll make it work, and it'll be fun.
Mm.
So kind of starting a new chapter, doing a lot of new things. So it'll be good. But yeah, just kind of let's just go right into the episode. We brought on Caitlin Hirschler to talk about environmental compliance and even the intersection between material science as she graduated from Georgia Tech, like David and I, with her bachelor's in material science and engineering. And so she basically covered her considerations. We walked through different hypothetical scenarios and the importance of environmental compliance and ethical considerations, product design, and just like material selection, things like that. So, with all that, David, I wanted to see if there was anything you wanted to emphasize before we get into the episode.
Yeah, I thought it was very interesting as it's kind of a new role and that we really haven't heard about before. But she's had multiple different roles in a bunch of different fields. And so it was really interesting hearing about how she's able to combine everything that she learned to think about how she wants to move forward. And so I thought it was very interesting hearing her talk about environmental compliance, what it means, how can she affect a program. And then she talked a lot about like the soft skills that go into making a good engineer. So I thought it was very interesting to hear about all the different aspects of her job and what she works on to then finally create like meaningful impact on the program to where she is comfortable sending off products without having like the fear of like hurting the environment or hurting someone. So I thought that was a very interesting role that we got to hear about that I didn't really know about before.
Yeah, for sure. And I think that was an important conversation to have from you mentioned soft skills, emotional intelligence, and even this was pertinent to my role, which we dove into a little bit, but in industry, especially if you're on the regulatory side or quality engineering side, maybe even any role, there may be a time where you have to kind of push back and say no, but there's a way to go about that makes you a strong engineer. And that means not just saying no and not really explaining why, but it's, hey, we can't do this because of X, Y, and Z, but some alternative pathways, or here's what we can do to make it compliant or to adhere to our quality standards. And just explaining all of that because different functions, they have different feelings towards quality and regulatory compliance. So that was, I think, a very important part of the episode. And then she also wraps up the episode by getting into kind of expectations around engineering and what we think when we are engineering students, what are the potential pathways and how it might be just kind of the expectation to rise up the corporate ladder and eventually go into management, but there are a lot more pathways. And so we cover a lot in this episode. So I just wanted to say before we get into the episode, if you guys could, you know, leave a review for us, leave a 5-star review and a rating. That would be extremely helpful and it'll help push our podcast to even more MSCs around the world. So without further ado, let's get into it. Hello everyone. For this week's guest, I am happy to introduce Caitlin Hirschler, pronouns she, they, environmental compliance engineer at Bose Corporation. Caitlin graduated from Georgia Tech, like David and I, in 2018 with her bachelor's in MSE. She already has a rich background ranging from R&D at Porex, and if you guys recall, we've had a previous guest, Robert Kiplinger, who was also at Porex, to also now material development to her current role in environmental compliance. So for this episode, since it's a pretty unique side of material science and engineering, we want to just generally focus on Caitlin's experiences in environmental compliance so far and how MSCs can contribute to this field. Thank you so much for joining us today, Caitlin. We're looking forward to getting right into this episode.
Same.
Great. Well, let's jump right in. I think the first question is, let's start by defining what an environmental compliance engineer does. Kind of intuitively, I think we all think about reducing our carbon footprint or reducing waste, but I'm sure there's a much broader range of fields or applications that you work on specifically.
Absolutely. So, particularly at Bose, environmental compliance is much more of a regulatory position than a sustainability position. Obviously, as these past few years can tell us with restricting common chemicals like PFAS, BPAs, bisphenols, and all of that, sustainability and the regulatory compliance pieces are really starting to come together. So, my responsibilities day to day are pretty much ensuring the environmental compliance regulatory piece of all of our products, as well as helping future plan for material restrictions as they come out of different countries, since Bose is a international corporation. So we have to pay attention to the regulations coming from not only North America, but Europe and also Asia as well. So kind of in that piece, mostly working with products, ensuring their compliance. It's a very, very interesting, diverse little field. I really enjoy it.
Interesting. So speaking just from the perspective of medical devices, I know that when it comes to regulatory compliance and there's so many notified bodies and maybe even like standards to kind of adhere to, what does that look like in your space? And is there any like room for interpretation with that, or is it pretty cut and dry, like this is what you need to hit and it's pretty clear how to understand kind of what you need to be compliant to?
So that's like a really interesting question, because there's stuff that is regulated, throughout the world, but there are also stuff that should we restrict, but is not restricted everywhere? Absolutely. So it's kind of up to not only the company, but the engineers in these positions to make those kind of proposals and judgment calls, like looking for the future. While your other MEs and your plastics engineers, like they are going to be aware of how a product works, kind of what the material is doing in it. But we can use that background that we have as MSEs to kind of look forward and be like, all right, like, no, for real, like PFAS is causing like, endocrine disrupting issues. Like we can never get out of the environment. We can understand a different side of the chemical that would make us more eager to jump out of certain materials than others, like phthalates. We still can use phthalates in the US, they're banned in the EU. So if I as an MSc knew that, because I used to design rubber for commodity wire and cable companies, I was using banned phthalates from the EU that are allowed in the US. If I had known that at the time, part of my product or my program might have been, how can we work out of these? So might have gotten a little off track there. So drive me back onto the track.
No, that was perfect. I was just curious, like what motivated you to kind of transition to this environmental compliance phase of your career, first and foremost.
Absolutely. And this is something I'm so passionate about talking about, because one, I never knew this type of position existed when I was at tech. I kind of left tech with the idea that I wanted to be kind of like, quote unquote, a development R&D engineer. I loved the problem solving. I liked being able to research without having to do like research, because it's a little more technical than my brain enjoys going. But I've always loved the material science of it. Like, why are we using certain materials? Like, why are we using them for our products? So kind of just that knowledge interested me in general. But when I graduated tech, I realized that I'm, as a person, very passionate about sustainability, particularly in fashion. I knit and crochet, and so that really kind of leads to a textile sustainability passion for myself. But I quickly realized, as a polymer and textile engineer, I had no sustainability training in plastics, and so I kind of was like, damn, I definitely want to include this into my career, but I was not prepared for this out of college. Like, kind of, how can I make my way there over time? And so this, my position now at Bose is now my fifth job out of college. I thought I was going to be, and I graduated in 2018. I thought I was going to work for one company my whole time. Quickly learned that I am worth more than staying at a company that does not value me or my values. So that was a nice lesson to have learned and do. And so over time, I really realized that there's a lot of pieces of engineering I don't enjoy, which is operations, having to consider money. So like cost savings really does not get me going in the morning to try to do my engineering work. But trying to ensure someone's safety, quality, following regulations, like kind of like that black and white rather than an engineering gray piece, really let me step into the position and feel very successful, because I found out over working in manufacturing, which if any manufacturing engineers out there know, a lot of gray area, was very stressful for me when a plant would ask me to allow a formula to go through that, was not UL approved, or we were kind of letting that slide. I'm much more of a black and white person. And so this was a perfect fit to kind of balance my materials knowledge and my passion working with materials, working in consumer products, and then also that sustainability black and white piece, like helping encourage engineers to do the right thing when other people who are not engineers may not know how to communicate with a group of hard-headed, stubborn people.
So I'm very interested. When like a new product comes in, is your group mainly just the arbiter that says yes or no, this is going to be safe? And then to make that decision, is it mostly just research from online or third party like researchers, or do you guys actually do some of your own research for some new materials? If it's a little bit of a gray area, like you say, where you don't know exactly the effects sometimes.
Yeah, and there's always going to be that because there's so many chemicals out there. Like, think colorants. Like, you can change like probably like one, molecule, and like then you have a whole new colorant with a whole new toxicological like effects on people. So for a consumer product company like Bose, regulatory compliance is going to be like the base of where we're starting from. So that is kind of looking at like RoHS in the EU, which is specifically chemical restrictions in electronic products, or TASCA in the US, which is a chemical restriction program like in the US, and losing my train of thought, but I'm going to pivot into biocompatibility. Kind of, how do I look at this? So biocompatibility, I think, is really interesting to talk about when we're talking about consumer product, especially wearables. There is not a standard for that across the industry, even in electronics. And so imagine like you got a pair of, cheap earbuds from Walmart. They may not have done a biocompatibility analysis. So you don't know what kind of colorants or resins that are in the outside of those products that can either cause an irritation or a sensitization reaction. And so that's the kind of skill that I picked up at Bose and really enjoyed. Kind of, it's kind of like a product safety piece, but as I said, there's not really a standard to give you yes or no. You have to make that judgment call if it's a yes or no. There are some testing. So there is ISO 10993, and that covers like cytotoxicity, skin irritation, and skin sensitization. But not every chemical has that. So I do a lot of literature analysis. So looking at, since the EU restricts a lot of chemicals, they have a lot of reports. So I kind of use that to interpret. The US has different rules, and it's a lot of taking papers and interpreting it. I think that's what's so fun for me. It's kind of like a scavenger hunt of finding information. I'll just do a quick example. Like, I recently had to evaluate Prop 65 compliance on a resin that's super far out in development, and I found a compound in it that was restricted in both California and in the EU. However, like, I could tell that it was not the target category. So I was like, all right, like, both of these restrictions have conditions. So one of them had to do with transference of chemicals from the object to the skin. The other one had to do with risk of cancer. And so I was able to go in, look at research from like Australia, a report from 1990 that the Color Pigment Manufacturing Association in the US submitted to the report of carcinogens and evaluate that, oh, actually the chemical that I was worried about inside this compound is not bioavailable. We can use that. It's fine. So if I hadn't been able to go in and do that deep digging MSc research, if I kind of left it at face value at, oh, these are just these two regulatory pieces, I would have said, oh, no, we can't use this material. And that would have caused production issues. But because I had that ability to go in, read papers, extrapolate, really kind of do problem solving and analyzing, I was able to evaluate all right, it looks bad, but it's actually not. Chemically, biologically, it doesn't do the things that we're concerned about. And that's a special kind of, I think, benefit of being an MSc, because we know that science exists rather than taking it at face value.
I love that. And I appreciate you kind of walking through a general example too that paints the picture in a much more clearer way. And so going on that, like let's say in this biocompatibility example, hypothetically, what kind of problem solving tools or skill sets have you developed over this specific role that has really helped in, you know, kind of that intersection between your material science background and now like this environmental compliance?
I think it's actually a mix of those two, and also these interpersonal skills that I think are so critical for engineers to have and to use and to build. For an example, this is a perfect, I think, an intersection of that. As we all know, business processes are not perfect. We're always trying to improve, get ahead of the process. So for one of my recent programs, I come into it late in the game. And so when I got the pigment package from our manufacturers to review, they really already started working on things. I'm pretty late there. So when I look at it, I use my MSc knowledge to be like, all right, I know this is for a blue product. You sent me exclusively orange pigments. So and so for that specific project, I had something similar like that happen to me 4 times. And so every time I open a package, it's like, all right, this doesn't have any pigments in it. These are dispersants, these are mordants, these are stuff that help with the chemical reactions and stuff, but it's not, what I'm looking for. And so then I have to address that as a business process piece. I'm about to tell a program that's pretty far along that the information that I'm getting is not accurate, and that we really need to kind of push stuff to make this happen and ensure that we have compliance. So at the time, it's kind of how do you reach out to program managers that may not have a great idea of your role and kind of the importance of why you're there. MSCs, I don't know if y'all have experience with this. I have found across industries, across people, that MSCs and material compliance does not always have the strongest argument for decision making for product managers. The Big Dig in Boston is an example. A concrete shelf fell during the Big Dig, and it was because they used a quick set epoxy instead of the mandated slow set epoxy. So there was a faster creep. So it's a very MSc thing to experience, having to validate why you're making these decisions. And then on top of that, you not only do not people not understand the MSc, it's kind of how do we communicate effectively with people, and that's really where that emotional intelligence comes in. So it's about bringing the right people into the conversation, ordering it in a way that formatting your emails in a way that makes sense and is readable, not dumping information on people, more of kind of giving them a way to flow through your email where it's here's the problem, here's how I understood that, here's my fix for the problem, here's how we'll move forward. It's not just about being the smartest and being able to figure out that information, being able to communicate it out effectively so that people listen to you is so critical in every industry. And I don't think enough engineers get trained on it or developed on it over time. So it's something I'm really passionate about, of helping to build younger engineers, and also kind of spreading around my team.
Yeah. So like you mentioned, emotional intelligence is what you consider a very valuable skill for material science positions. But something I'm curious about is, like you said, it's definitely not emphasized when we are graduating. Technical skills are very emphasized. So, one, what do you think is the largest problem you normally see young material science engineers make that don't consider emotional intelligence? And two, what do you think are like some common things that they can work on, or like, I guess, like things that they can implement in everyday life to try to work on their emotional intelligence?
Absolutely. I'm going to give a very specific example. I've worked at a bunch of different companies, manufacturing, corporate, so I get to pull from a lot of backgrounds. So I was working at a commodity rubber manufacturing, rubber wire and cable manufacturing plant in Rhode Island. And when I was hired, I was not just hired for my ability to compound rubber, which in itself is a very unique MSc skill. Very fun if anyone is interested in compounding rubber. I got out of it, but love it. But because there was such a communication problem between the corporate rubber like cost savings development engineering and the actual production plant itself, like the person before me, quite literally, they would get into screaming matches. And so like I've seen this all over manufacturing, and I don't know if it is a older generation thing, because I've never seen younger people scream at other engineers, but there is just this emotional intelligence lack, this ability to work with other people lack, that I think a lot of older engineers, especially in manufacturing, have. And that's extremely challenging to work with, because like how do you communicate information when someone is so resistant to that? And the ways you can look at that is you'll start to notice, oh wait, how do they like to communicate? Is it in person? Is it call? Is it email? Is it by like a quick message? What's the most, how do, because you want to communicate with them, that's your goal. It's not like what's your favorite way, it's how do you get that communicate the information to the other person. So it's really kind of taking a step back and being like, all right, how do they want information like given to them, like the format for the vehicle, but then also it's the format, like how do you display information so that someone can take it and do something with that? How do you format those emails? How do you format those requests? How do you format those like reports, those findings? Some companies have like a very standard process, but not everyone does. And so it's kind of on you to try to build that. So that was a big thing I did at that plant, because for example, a lot of times I was the one who held all the formulas for all of the mixes. And so I would get calls in the morning being like, hey, we ran out of this grade of plastic. We found this one in the corner. Can we go ahead and use it? We've done it before. I just need you to sign off on it. So it's me having to, learning how to say no and be like, all right, like, no, you cannot do that. This is why. And it's also a confidence piece, because like how do you tell the operations manager who's worked there for decades that you as a young engineer being like, no, like this is what's right and this is what's wrong, like I know ethically and what company wide like we're supposed to be doing, this is not it. And yeah, so I think that all goes together: emotional intelligence, how you communicate, understanding that other person. And it's not easy, because no one teaches you how to do it.
Yeah, for sure. That's like a growth area for me, I feel, is learning how to say no. I'm in the design assurance space in medical devices. So there are components of my job where it is, learning to say no. But I wanted to ask you, based on that, when you're in those situations where you have to say no, do you like, I understand you explain why, but do you also offer alternatives or like things to look into to get to that yes?
Yes, and I think that is the critical piece. No, like you cannot be successful if you're saying no, but you don't offer a solution. You may not know the solution, but us as engineers, we are trained on structures to find solutions. So you don't just go in there and being like no, and this is why, and kind of flying off your head. It's kind of no, this is why, to get them to your same level, and then this is how we move forward. And a lot of stuff in engineering, especially in like consumer products, stuff that has shorter lead times, you have to do a lot of dual development, dual analyzing. You may be working on one solution but also have another one going at the same time. So you also have to be considerate of that, especially with schedules. It's so when I like, so currently in my job, if I'm like, hey, we can't use that pigment, I will always come up with like, hey, here's some alternates that you can use. I know that this time deadline is here. Like, as soon as you can get that to me, I can turn it around in X time. So it's also that piece. It's being a part of the problem solving. Something that I think is interesting that I've got shoved into me while working at Anheuser-Busch, and I don't even think about consciously now, is the 5 whys. And that essentially, the example of that is if you trip on your manufacturing floor, you trip, scrape your knee on a hole in the ground. You don't ask, okay, there's a hole. My problem is the hole in the ground. Let's fill it. That'll solve the problem. No, you ask, why was there a hole in the ground? Oh, because that fork truck that goes over it 7 times a day has a thing on the back of it that keeps scraping out that piece of it. And then we solve that, and that's the problem. And that's it. And so I think as MSCs, something that we can do because we have such a complex understanding. Like we're multifaceted. Not only do we have like some little ME stuff, some double E stuff, some project management, we have that material background that lets us understand why we can do things and why we should not do things, and kind of do it that way. I'm for people listening. I'm kind of moving my hands in a wiggly pattern, showing a path forward. So it's kind of working it out.
Yeah, definitely. So, kind of taking a step back, and you've talked about your passion for sustainability. I wanted to ask how much of your role is centered around your company's long term sustainability goals versus that environmental or regulatory compliance, or is there kind of a integration between the two?
There's definitely integration between the two. So at my current company, there is 3 different departments concerning with environmental in their title, and then another department that is also involved in like circular economy that's not held by one department in general. So for my position at the company that I'm currently at, I am focusing mostly on regulatory things at this time. However, that's just a resource thing. The company in general is we're thinking, and especially me, is thinking, how can we look ahead? So I know that PFAS is going to get regulated in the EU by like 2027. PFAS is used in everything, very, very much so. So it kind of like that forward-looking piece of that is while that will be regulatory, right now it's just a sustainability thing because it's not good for us. So, like, how can I plan to not only remove that by the time it's regulated, but also remove it in general because we don't want to be using it. Like, just in general, like how we don't really want to be using PVC. Bose does not use PVC anymore. Some shoe companies still do. I used to compound the outsoles of shoes, the rubber and the foams. Very fun job. Loved that job. So
Awesome. Well, yeah. Well, we're talking about this compliance. One thing we have to consider, like you said, is that the compliance around the world changes very rapidly, especially when we talk about Europe. It usually has higher regulations and then Asia has lower. So as we produce more goods overseas, what does that mean for us here in the US when we ship in these goods? How do we first quantify and make sure that it meets our standards? And then how does that affect the difficulty of your job? And then how does that kind of account for accountability for companies to follow these rules change as you manufacture in different parts of the world?
yeah. So for established regulatory pieces, because Asia is doing so much manufacturing for the rest of the world, and a lot of companies work internationally. So let's say like Bose is an international company, and like we sell and we sell, Asia, EU, US. There's laws in the EU that we don't have in the US. But since we're not going to make separate products for every single region, most consumer product companies are going to comply with the most aggressive regulations, which would say the EU. So in general, just because we're all looking at the EU as kind of forefront, any manufacturer that you work with in Asia that is also working with other companies selling in the EU, they know this. This is not their first rodeo. RoHS has been in place for almost decades. China restricted OCs, volatile organic compounds, like just a few years ago, and that's not restricted other places. So it's necessarily a problem of the manufacturing in Asia and not being able to comply with the rest of the world. However, what I think we can speak to this is how do you monitor all of those? Because it's, the EU is getting more, the US is getting more. I mean, Maine is banning PFAS in certain, restricting PFAS in certain like clothes, furniture, kids' toys. And then companies that have PFAS in their products have to register with the Maine government in 2024. So that's the bigger question, is how do we track these and then communicate them back to the manufacturer? They have a team that is looking at it too, because that's part of the manufacturing process. Since us as the customer and all customers have a regulatory piece, there has to be someone on their team that deals with that. Otherwise, one, you shouldn't probably work with that manufacturer if there's not someone to help you, because it's impossible to do that on your own. You have to have someone on the ground in Asia to really be working hand in hand at the plan. And but you're right, tracking that stuff is so hard. There is a lot of different like software programs, like there's like all sorts of online databases that you can pay for that send you newsletters to track, like that help track it and stuff. But it's also kind of figuring out like what works best for like you and your company and the resources that you have. And I think that's the fun part, because this is growing. So I don't think Apple might be there, because Apple is very large and has a ton of money to do things, but a lot of companies are still in the process of figuring out, all right, what's the best way to handle our environmental compliance piece. For so many years, they got away with just being able to like, oh, don't worry, there's no lead in it, there's no cadmium in it. And that was good enough. But in the past 5 years, like especially since COVID, the exponential increase in regulations across the world is absolutely bananas. And I think another piece of that is not Asia and having the stuff come here and how it's compliant, and once it gets here, it's the formative chemicals, like the precursors for a lot of the stuff that goes into the product, would be banned if it was used in the US or the EU. But since it's in Asia, they can use it. And so we're you have to think about, all right, we're exposing these operators to chemicals that we don't allow in the US and the EU. They're not on our products, they're not going to be getting to us, but it's also kind of that ethical piece of how do you look at that? We're using products that like once they're cured, they're fine, but in their uncured state, like if people aren't wearing proper PPE, and this, it's a communication piece. It's how do you business process that? How do you kind of push through business silos to make a process better? And I don't also MSCs don't really think about that, but I think that's perfectly aligned with that kind of 5 why piece. So for an example for me at Bose, like I just talked about like colorants. I recently found a colorant at the very end of a program that I didn't like and I wanted to reject. And kind of the program managers were like, all right, why are we so far at the end of the program and we're hearing this? And I'm like, you're absolutely right. Let's take a look at how we do this and how we can shift what I'm doing to right when you guys are developing the color. So I'm not just thinking about like, hey, like, what do I need to do? Like the task I need to do. I'm kind of looking at holistically being like, how does what the work I do affect the rest of my, like the program, like the team? And like, it's also annoying to me to get at the very end, because then I have to do all that emotional labor to get them to understand why I'm telling them no, instead of at the beginning where like, if I told them no, then it'd be like, oh, okay, then we can just change quickly.
Right. That makes sense.
Mhm.
Yeah, for sure. So I want to talk about like a hypothetical situation that just came up when you were talking about all of this, which is maybe if you were to encounter a situation where you feel the regulatory standards that you need to comply to may not be totally sufficient, or you feel maybe your company could do even more. How would you navigate that type of situation? Like, let's say your materials background tells you that something's not right. Maybe you're still adhering to the standards and the quality that you need to, but you feel like you might need to do a little bit more. How would you kind of go about that type of situation?
Yeah, that situation I would handle like any other proposal that I have. That's a hard hole for MSCs to be in, because it's like we have a very strong opinion, and how do you get someone to recognize that and when they might not? So definitely thinking about the same way that I would think about a lot of things. It's how do you structure that request so that it makes sense. So it's the all right, why? And then what does that look like for Bose? How will we do this at Bose? And then like, and it's a company, so there's like, while my job and a lot of the work I do does not have a financial aspect to it, like when you're doing a pitch like that, removing a chemical that's not restricted and there's not another driver, you really also have to put that money piece in there. I love being able to take my regulatory excuse and being like, do what I want because legally you have to. But this is where it gets that gray area. It's really like breaking it out into those different components. Is it, and what angle you're going at? Is it we're a premium product, so our customers don't want to be don't want to know that they have this in their product, or a safety thing like oh, like, here's research and evidence that, use of this with that causes X. And really building your case, I think is the best way. I'm a very feely person in the way it's like, we should not do it because we should not do it. But the people who are making decisions don't think like that. General management, so many, they're not one track minds. They are considering every little fluffy bit that I personally don't care about. So I have to convince someone who has all these other considerations to consider my point the most important point.
Sure. So going off of that, how do you think this environmental compliance role will evolve in the next 5 to 10 years versus kind of the impact that you're making now? Whether you choose to stay in the environmental compliance role or not, I just wanted to get your perspective on how you think the evolution of environmental compliance will pursue.
I think it's going to be different at every company, especially how they break up their sustainability piece of it too, because environmental compliance, like, used to just be regulatory compliance, used to just be in product compliance. But we can all see now that it is sustainability is marching slowly integrated to it. So I think it's going to be the question of how do companies balance not only their environmental compliance piece, but also their sustainability piece. Do those teams merge? Do they get bigger? What does that look like? I also think it's just going to be growing exponentially. I mean, just right off the bat, I can give you like 5 things in the EU right now that like could be like that I'm looking at as environmental regulations, but they also could be handled or touched by other parts of the company. The EU battery restriction, all batteries for a lot of electronics are going to be mandated to be removable by 2027. ESPR, that is an eco design sustainability regulation that is being developed that will affect how we approach designing of products and looking at the considerations. That's later in the decade, but like still develop. Right to repair, that's another EU one. It just, there's just so much. And that's not even chemical restrictions. And then we talk about PFAS restriction, bisphenol restriction, flame retardant restriction, because they want to, remove all of the halogen flame retardants and stuff. So it's just going to get bigger and more complex and have more business complexities in it. So people in this position are going to have to be much more diverse, much more able to handle more complicated inputs. I think like your inputs are going to get more complicated for the output that you have to deliver for your team. I think that's just going to be it more and more. Anyway, I think this position is going to grow. Position is going to grow, industry is going to grow. More money is going to be invested in it because they have to, because it's going to be legally mandated that they do.
So, so I'm just curious, how many people in Bose actually work on environmental compliance? Like the scope seems massive, but like you said, the importance is only going to grow.
Absolutely. So Bose is a special case as we are doing structural changes over the past 4 years, which is more of a company-based objective that I would say really the team-based objective. Currently, the setup is me, another environmental compliance engineer, and our manager working on all of this. I think personally, I would like a 3-person team in my manager, get a lot more work done, but also it's how do you grow that team into other people so that you can spread out that work, because like, is a battery regulation like how is that really regulatory or environmental compliance when I could be looking at chemicals? And so you can look at someone who's working in energy efficiency compliance, which does have a regulatory piece on the team, and how can we take this person who used to just be a double E doing very technical electrical engineering work and kind of pivot them into help with circular economy, eco design, energy efficiency. So I think it's also how you diversify the other parts of your compliance teams as other parts of design become regulatory compliant necessary.
Great. Well, yeah, thanks so much, Caitlin. I think we just want to wrap up the conversation about your expectations of engineering. At one point before, you mentioned that you felt there was an expectation for you to reach senior management and just continue up the corporate ladder. Do you still feel that way? And then what do you wish that these young engineers that are coming to the field knew what you knew back when you started?
Absolutely. I feel at Tech, I was encouraged slash forced into a very specific manager prep like mode Like very few engineers I know graduated college without being like, oh yeah, I'll probably get my MBA, like later down the road and then go into management. My parents worked in management. I think it's kind of like the expectation of how you will grow over the years. Like instead of getting more technical, if you want to go technical, you go into research, quote unquote. If you want to work in corporate, you go into corporate engineering and then you go into management. I realized that a lot of the skills that are beneficial for general management. So it's wanting to do something completely different every day. It's having to take in a lot of different inputs and kind of be more of a generalist, having to consider all different points and making hard decisions that may not it's not perfect, but you're taking all your inputs and kind of doing what you think is best. For me, I am much more of, I want to dive into one topic and be that topic's like advocate for whatever industry that I'm in. I've realized I get so much more passionate about diving deep in a topic and then managing like peers, like managing like not necessarily managing a coworker, but helping like product manage like a program that I'm working on in my coworker sense. I don't want to have to go, like 3 levels up and have to make decisions across the entire product compliance, product regulatory division when I'm clearly so interested in this technical aspect of environmental compliance that I would have to lose if I grew and as a general manager. I am much more focused now. I'm like, oh, technical managers exist. Like I can see myself running my department in 5 to 10 years. Like I was like, and I can even grow like, depth in my role, like be a principal engineer like in this and be really powerful. I think it's kind of pushed on young engineers that being a manager and having that typical traits that a typical engineering manager will have is kind of the goal, but it doesn't have to be. Like it's okay to be like neurotic and wanting to really be precise and focus in on stuff, even when on a different role that may not be your best solution. It's just probably not the role for you then.
I love that. And I appreciate you sharing that perspective as well, because I think that is something that we really want to share in this podcast is that it's a very versatile field, but also even when you're kind of determining your paths forward, there are a lot of options, especially as an MSc.
You do so much as an MSc, every industry, every role. You're so flexible.
For sure, for sure. Well, thank you so much, Caitlin, for joining us today. It was really interesting hearing about this environmental compliance space and just hearing your insights and perspective with everything. I really am grateful for you joining the show.
Awesome. It's been really great talking to y'all.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSc Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.